Hello everyone, welcome to the control systems. This is part 5 of lecture 9 root locus technique. Uh, in this section we'll discuss root locus for positive feedback system. Okay, basically how to sketch it. Consider this simple system and then this is a positive feedback before we discuss a negative feedback. And if you do the block diagram reduction, you will end up have this closed loop transfer function with this minus sign. So this is it have magnitude of 1 and the angle of k times 360. Okay. So there are some certain rule that we need to follow, which is more or less the same as the previous the negative feedback, but with a little bit of modifications and a little bit of change. Rule number 1 is number of branches. It's the same as for negative feedback. Okay. And number 2 is about symmetry. So it's again the same argument as a negative feedback. You can apply that rule. There's no change. Number 3 is about real axis segment. Okay. So on the real axis, the root locus for positive feedback system exists to the left of the even number of the real axis, finite open loop pole and or finite open loop 0. And rule number 4 is starting and ending point. So the root locus for positive feedback system begin at finite and infinite poles and ends at finite and infinite 0. Okay, the same as the previous the negative feedback. However, in rule number 5, you need to change a little bit. Before 2k plus 1, but in this case, this part is 2k pi. 2k times 180. Okay, this is the intercept, this is the angle. And something to note that the imaginary axis crossing can be found using root locus programs. Okay? And in the search of j omega axis, you are looking for the point where the angle add up to a multiple of 360. And the breakpoint are found by looking for a maximum value of k. The break-in point are found by looking at the maximum value of k, a minimum value of k. Okay, so this is the end of this video. Thank you.